Hello guys, good morning guys. This is Srinivas from Peruri, math educator. Yes, look at the board. Let A naught, A1, A2, A3, A4, A5 be a regular hexagon inscribed in a circle of unit radius. Then the product of lengths of line segments A naught, A1, A naught, A2, A naught, A4. Okay, yeah guys, look at the board. Yes, A0, A1, A2, A3, A4, A5B, a regular hexagon inscribed in a circle of unit radius. Then the product of the lengths of line segments A0, A1, A0, A2 and A0, A4. Right. So this is the circle. Okay, right. A regular hexagon inscribed in a circle. What is the A0, A1, A2, A3, A4, A5? Okay, right. Now how to find the vertices of regular hexagon? Generally, parametric equations are r cos theta, r sin theta. Unit radius, this r is equal to 1 beta. Right? 1 into theta equal to 0 on the x-axis like this. Okay, right. So, theta equal to 0, cos 0 and sin 0. Cos 0 is equal to 1, sin 0 equal to 0. So, that means 1 comma 0. A1 is equal to, yes, this one is 60 degree, regular hexagon. Theta is equal to 60 degrees for that one. So 1 into cos 60, 1 into sin 60. Cos 60 is equal to 1 by 2, sin 60 is equal to root 3 by 2. Now A2. Okay, this one is 60, 120, 180 this one. So cos 120, sin 120, r is equal to 1 beta. Cos 120 is equal to cos of 180 minus theta. If the angles are 180 plus r minus theta, 360 plus r minus theta, then the trigonometric ratios cannot be changed. Sin, cos, tan, cot, secant, cosecant, secant, okay, secant. Right. So the signs are depends on the given quadrants. So here 180 minus theta. So on of course 120 can be written 90 plus 30 also. Okay, right. Yes. So 180, there is no change in the trigonometric ratio, cos 60. But 180 minus theta belongs to second quadrant. In the second quadrant, okay, sine cosecant positive by all silver t comes. So negative sign. So cos 60 is equal to 1 by 2. Okay. Sin 120 is equal to sine of 180 minus theta or 90 plus 30. Okay, sin 180 minus theta is equal to sin theta. Sin 60 is equal to root 3 by 2. Like this. Okay, right. Cos 120 is equal to minus 1 by 2. Sin 120 equal to root 3 by 2. Now A3 is equal to, obviously this one is 1 comma 0, this one is minus 1 comma 0. Why? Because this one is 1 unit, lies on the x-axis. So minus 1 comma 0. A4 is equal to, yes, this one is equal to, A1 is equal to how much? 1 by 2 comma root 3 by 2. But it A4 belongs to which quadrant? Which quadrant? This one, third quadrant. In the third quadrant, x negative, y negative. So that minus 1 by 2 minus root 3 by 2. Simple that one. Okay, right. So A0, A1. So A0, A1 means distance between these 2 points. Okay, right. Distance between these 2 points. So here x1, y1, x2, y2. x2 minus x1 whole square plus y2 minus y1 whole square. After simplification, what will get? 1. Now A0, A2. Yeah. A0, A2. Right? Applying the same formula, distance between the 2 points. Yeah. This one is, okay, x1, y1, x2, y2. A2, x2, y2. So this one is minus 1 by 2 minus 1 whole square plus root 3 by 2 minus 0 whole square. So this one is minus 3 by 2. LCM is equal to 2 minus 1 minus 2 minus 3 minus 3 by 2 whole square plus root 3 by 2 whole square. After simplification, what will get? Root 3. So LCM is equal to 4. 9 plus 3 is equal to 12. 12 by 4 is equal to 3. Like this. Now A0, A4. Yeah, this one is equal to x1 by 1 and this one is x2 by 2. So this one is minus 1 by 2 minus 1 whole square minus root 3 by 2 minus 0 whole square. So this one is minus 3 by 2. Okay, right. Whole square plus root 3 whole square means root cancel. 2 square means 4. LCM is equal to 4. 9 plus 3, 12. 12 by 4 is equal to 3 root. Okay, guys. So A0, A1, A0, A2, A0, A4. That is equal to A0, A1 is equal to 1. Like this. This one is 1. And this one is root 3. This one is root 3. Yes, root 3 whole square. This is the answer. So mainly this one is How to find the vertices of the regular hexagon? That is very important. Okay, right. Parametric equations. The parametric equations of the circle. Okay, right. So this one is the center. This one is the center. Yeah. 0, 0. Right. This one is equal to radius. Equation of the circle having the center 0, 0 and radius r is x square plus y square is equal to r square. Here r is equal to 1. Right. So parametric equations of that type of circle is x is equal to r cos theta, y is equal to r sin theta. The parametric equations, I repeat, the parametric equations of the circle like this: x square plus y square is equal to r square is, okay, x is equal to r cos theta and y is equal to r sin theta. That's it. Okay, then substitute those two values in that circle equation. It is satisfied by two equations: r square cos square theta plus r square sin square theta, r square common cos square theta plus sin square theta equal to 1. That's why let us take the points be a naught is equal to r cos theta, r sin theta, r is equal to 1. Theta equal to 0. This one is x-axis. Okay, guys. Yeah, this one is x-axis. Yes. Now, okay, theta equal to 0. Cos 0, sin 0. Cos 0 is equal to 1, sin 0, 0. Right. Next one is a1. a1 is equal to same r cos theta, r sin theta. Theta is equal to 60 degrees. Why? Because regular hexagon. Okay, right. So, theta equal to 60 degrees. Now, okay, cos 60 is equal to 1 by 2, sin 60 is equal to root 3 by 2. And a2 is equal to, yeah, this one is 60, this one is 120 angle. So, cos 120, sin 120. Cos 120 equal like this. Sin 120 equal to like this. Then, minus 1 by 2, root 3 by 2. a3 is equal to quite opposite. This one is 180. Cos 180, minus 1, sin 180, 0. Okay, right. So, this one is minus 1, 0. Yes, a4 is equal to simply like this. Okay, this one is a1. a1 is equal to how much? 1 by 2 root 3 by 2. But this a4 belongs to which quadrant? Third quadrant. In the third quadrant, x negative, y negative. Simply quite opposite. This one is minus 1 by 2 minus root 3 by 2. Now distance between a0 a1, a0 a2, a0 a4. We get the required answer. If two distinct chords drawn from the point P, Q on the circle x square plus y square equal to px plus qy, where pq not equal to 0, are bisected by the x-axis, then which option is correct? Look at the statement. If two distinct chords drawn from the point P, Q on the circle x square plus y square is equal to px plus qy, like this figure. Yeah, given circle is x square plus y square is equal to px plus qy. So that implies x square plus y square minus px minus qy is equal to 0. What is the conclusion? Look at this. X square plus y square, okay, ax plus by equal to 0. X intercept is equal to p, y intercept, and it is also this equation not containing constant. So indirectly it is passing through origin like this. Yeah, this one is x-axis and this one is y-axis. So x intercept is equal to, yeah, so this one is a, yeah, p comma 0, and this one is q, this one is b, okay, right, 0 comma q. So actually we have the formula equation of the circle having the intercepts a comma b is, okay, x square plus y square minus ax minus by equal to 0. X intercept is equal to small a and y intercept is equal to small b. Or indirectly equation of the circle passing through a comma 0, 0 comma b and 0 comma 0 is x square plus y square, okay, minus ax minus by is equal to 0. I repeat, equation of the circle passing through origin and passing through origin means 0 comma 0, a comma 0 and 0 comma b is x square plus y square minus ax minus by equal to 0. Here x-intercept is equal to a and y-intercept is equal to b. That's it. This value is equal to, of course, it is passing through origin. This one is. Okay, right. This is equal to p. And this one is equal to q. Right. And look at the board. If two distinct cards, it is one of the card. Okay, right. Distinct cards are drawn from the point like this. So this one is, say, one point P comma Q. Like this. One card. Right. It is intersect x-axis M. Okay, right. Drawn from the point P comma Q on the circle x square plus y square equal to px plus qy are bisected by x-axis. Bisected. Okay, right. So capital M, this one. Understood? Right? So I suppose that this one is equal to, say, yes, x1 comma 0. Right? So now listen beta. Equation of the chord equation of the chord or like this, if capital M x1 comma y1 is the midpoint of the chord, like this, right? If m of x1 comma 0 is the midpoint of the chord, then S1 is equal to S11. We have the formula. Okay, right. If E of x1 comma y1 is midpoint of the chord, okay, midpoint of the chord, then midpoint of chord of the circle, S is equal to 0, then S1 is equal to S11. S1 means x1 like this. If S is identical to x square plus y square plus 2gx plus 2fy plus c, then S1 is equal to x1 plus y1 plus g of x plus x1 plus f of y plus y1 plus c. And S11 is equal to x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. These are notations. So S1 according to this, okay, right? So x1 plus y1 minus half beta this one. Okay, why? Because 2g half, that is equal to g. So this one is, yes, 2g is equal to minus p. G is equal to minus p by 2 into x plus x1 minus, q by 2 into y plus y1 is equal to 0. Understood? But here capital M is equal to how much? x1 comma 0. y1 is equal to how much? 0. So x1 plus y into 0 minus p by 2 into x plus 0 minus q by 2 into y plus 0 is equal to 0. So that implies x1 minus px by 2 minus qy by 2 is equal to 0. That is, one second. Yeah. S1 is equal to S11, right? Now this implies S1 is equal to S11, yes, x1 like this plus y1 plus, okay, right. Now the 2j is equal to minus p. So this one is minus p by 2 into x plus x1 minus q by 2 into y plus y1 is equal to, right, x1 square plus y1 square minus px1 minus qy1. But here m is equal to how much? x1 comma 0, y1 is equal to 0. So that implies x1 plus y into 0 minus p by 2 into x plus x1, okay, minus q by 2 into y plus 0 is equal to, right? Now x1 square plus 0 square minus, this one is a p into x1 minus q into 0, minus q into 0. Now look at the board. X1 plus y into 0 minus p by 10 x plus x1 minus q by 10 y plus 0, like this. So this implies x1 minus p by 2 into x minus p by 2 into x1 minus q by 2 y is equal to x1 square minus px1, right? But it is passing through, this card passing through p comma q. It is passing through, it is passing through, yeah, p comma q. So x is equal to p, y is equal to q, like this, x comma y. So px1, okay, right, minus p into p by 2 minus p by 2 into x1 minus q by 2 into q is equal to x1 square minus tx1. Okay guys, now this implies, yeah, now look at this, yeah, px1 common is 1 minus 1 by 2. Okay, right, now p square by 2 minus q square by 2 is equal to x1 square minus, okay, right, px1, right? Now this implies 1 minus 1 by 2 means 1 by 2, 1 by 2 p into x1, okay, minus p square by 2 minus q square by 2 is equal to x1 square minus px1, x1 square minus px1, right? Now this one is, this total equation converted into a quadratic equation, right? So here x1 square minus px1, shifting the side, minus p by 20 x1 plus p square by 2 plus q square by 2 equal to 0. Okay, right? Yes. Now so this implies x1 square, yeah, minus px common p into, yes, 1 plus 1 by 2 into x1, okay, plus p square plus q square by 2 is equal to 0. Now x1 square minus, okay, 3p by 2 into x1 plus p square plus q square by 2 is equal to 0. It is a quadratic equation. It is a quadratic equation in x1. It has two roots actually. Okay, right. So here, if two distinct cards drawn from the point P of, okay, alpha comma beta, okay, right, on the circle x square plus y square equal to, yeah, px plus qy are bisected by the x-axis. Bisected by the x-axis, then what the relation? So roots are real and distinct. Real and okay, real and distinct means delta greater than 0. Okay, roots are real and distinct. Distinct means delta greater than 0. That means b square minus 4ac greater than 0. So here a x1 square plus b x1 plus c is equal to 0. Now b is equal to how much? Minus 3p by 2. Minus 3p by 2 whole square minus 4 into a is equal to 1. C is equal to how much? P square plus q square by 2, okay, greater than 0. Now, so this one is 9p square by 4 minus, yeah, this one is 2 times 2 into, yes, p square plus q square greater than 0. That implies LCM is equal to 4, yes, 9p square minus 8p square, okay, minus, all right, This one is 4 into 2, 8. Okay, minus 8q square greater than 0. That implies, 9p square minus p square, okay, p square minus 8q square greater than 0. So p square greater than 8q square. P square greater than 8q square. Yeah, fourth option correct. Fourth option correct. One second, beta. Yeah. Yes. Now, LCM is equal to, okay, right? One second. This one is 9p square by 4 minus 2 into p square plus q square greater than 0. Now LCM is equal to 4. Yes, 9p square minus 8 into p square plus q square greater than 0. Yes, 9p square minus 8p square minus 8q square greater than 0. Yeah, this one is 9 minus 8 p square minus 8q square greater than 0. Yeah, p square greater than 8q square. So this is the fourth option correct. Yes, look at the board. Look at the board. Yes, if two distinct chords drawn from the point p comma q on the circle x square plus y square is equal to px plus qy. Okay, right. Where are bisected by the x-axis. Right. So given circle is x square plus y square is equal to px plus qy. X square plus y square equal to px plus qy given. Now, actually that implies x square plus y square minus px minus qy equal to 0. So, equation of the circle passing through origin, x-intercept A, y-intercept B is of the form x square plus y square minus ax minus by equal to 0. So, comparatively that circle with this equation, x-intercept is equal to B, y-intercept is equal to Q, like this. This is x-intercept, this one is y-intercept. Okay guys. Hello guys. Right. Now, those are chords drawn from the point on the circle are bisected by the x-axis. So, capital M of x1 comma 0, okay, midpoint of the chord. Okay, midpoint of the chord of the circle. So, then we have the formula S1 is equal to S1. S1 means x1 plus y1 plus g of x plus x1 plus f of y plus y1 plus c. Of course, when the circle is like this. And S11 is equal to like this. Now, okay, right, x1 plus y1, yeah, plus 2g is equal to minus p. So, g is equal to how much? Minus p by 2, like this. X plus x1, yes, and f is equal to how much? 2f is equal to minus q. F is equal to how much? Minus q by 2 y plus y1. Okay, right, S11 means x1 square plus y1 square minus px1 minus q y1, like this. But okay, it is passing through, here capital M coordinates of capital MB x1 comma 0. So y1 is equal to 0. Put y1 is equal to 0 in this equation. After simplification like this. But it is this chord is passing through P comma Q like this. X is equal to P, Y is equal to Q. Don't write x1 is equal to P. Okay, it is passing through. Okay, this chord is passing through P comma Q. X is equal to P, Y is equal to Q. Like this substitution. Now, yeah, here px1 common. Yes, 1 minus 1 by 2 minus p square minus q square by 2 x1 square minus px. Okay, this total equation converted into quadratic equation. Okay, so this one is 1 by 2 px1 minus p square by 2 minus q square by x1 square minus px1. Shifting, okay, right side. So x1 square minus px1 minus p by 2 x1. Okay, plus p square by 2 plus q square by 2 equal to 0. Now here x1 square, right, minus px1 common beta here. So here 1 plus 1 by 2 into x1 plus p square plus q square by 2. x1 square minus 3p by 2 into x1 plus like that. It is a quadratic equation in x1. So ax1 square plus bx1 plus c beta. A is equal to 1, b is equal to minus 3p by 2, c is equal to like this. Now roots are real and distinct. Okay, right. So delta greater than 0. Delta means b square minus 4ac greater than 0. So b is equal to minus 3p by 2, 4 into a is equal to 1 and c is equal to this value. Right. Then, so this one is minus 3p by 2 whole square means 9p square by 4 minus 2 into p square plus q square greater than 0. LCM is equal to 4, 9p square minus 2 into 4 is equal to 8 into p square plus q square by 4 greater than 0. 9p square minus 8p square minus 8q square greater than 0. So 9 minus 8 is equal to p, okay, p square greater than 8q square. Okay, right. These two are very important for all the competitive track. Okay, right. Yes. Thank you guys. Love you all.